Today we will continue to discuss the hash and also some of the related things, especially regarding multi-set and multi-map. And until now, we have used the function find to search for item in map. But it will give us only one item. In case we have several items with identical keys, then we only get the first one. So far, we have not shown how you can retrieve or get all those values in types. And let's see examples. First, let's refresh our memory regarding all those basic things. In our main function, we could see that earlier we know that we have used a lot of map. Set basically the same as map, except that it has one value rather than two value pair in the map. Again, set you can put as one set of integer, and just like a map, it will automatically sort for you. And you can also always use insert to add more elements to a set. And of course, when I print it, you'll find out that it will be sorted in ascending sequence. And another important thing that set just like a map, you will not have a duplicate. So even though we have 2, 5, couple 3, etc., only one will appear. It's this basic property of set and map, which allows no duplicates. And what if we intentionally want to allow duplicates? Then we use something called multi-set. To use multi-set, we don't need to include new things, just regularly including set at the beginning, include set, and then we can use multi-set. For example, for multi-set, we have 2, 5, we have 2, 3, the same as this one. Now, if you print it, of course, I put an insert here to show you how you can add more value to it. And you can see that now we have duplicated 3 and 5. Now, this is extra space. Okay, so multi-set and this is basically set, and then we have used set before, and some of the functions to access set you can use, especially find. And we have seen map in the past, right? So we can create a map, and you will sort based on the key. First item is called key, and then we can also insert, add more node to it by using insert. I'm adding 8 here. So if I print out again, see first time 8 will map to Sanjay, now second time 8 will map to Mary. And you can see that there's no duplicate, just like a set. So you'll find out that only one item with key 8 will be printed. So this will be removed. Let me see. If you print out only one, this will be removed, and only 8 Mary will be printed. And then if we would like to keep all of them, allowing multiple items with the same key, then we use multi-map. For example, if I insert 6 John, then both of them will be printed. Again, they will be sorted based on keys. So you can run the program and see what kind of output we'll be getting. Alright, so and last time we also said that because map, where both map and set would automatically sort all items based on key values. And if the key values are primitive types or the simple type, such as integer or string or double or float or character, things like that, system already know how to sort it. And using a function called less, the default is less, L-E-S-S, less. And if we would like to have, if we change that to greater also system function, then everything will be reversed. It will be descending order rather than ascending order. So default is less. Less is a class, just like our class of functors, a class of comparator, and you can just like vector of int, greater of int, or less of int. Less is the default one. And now if we would like to use greater to reverse the sorting order, then we simply put it here. And since our key is integer, we use the greater of int here. So if you sort everything out, if you round it, you'll find out that you will be in descending order of the key values. Okay, so this is easy. Now we talk about the next one, unordered map. This is the one C++ introduced for us to implement hash table. So unordered map, unlike a map or set, now you won't order it based on key for us. You instead based on some kind of whatever internal function to decide where to store data. Usually it's based on the hash function that is actually used for the hash table. But it basically is a map, but it's not sorted. And say for example we have M4. So it just the way we initialize value, just like any map or set. In this case, just like a map, a two-value pair. And the first item is still the key. The second part is the value. Since usually for all the database purpose, you have a data item and you assign a key to it. For example, the key could be a student's SUID, and then based on SUID, you can access all students' information. The second part could be a pointer to external huge structure that is associated with each student. All right, so it's unordered, and first of all, you can print it out. It's just like a map. You can print it out, and order is basically unpredictable to us because it's organized based on some kind of hash, some kind of functions. Okay, so you have some initial thing you try to hash it, and since our key value is integer, and system already have a built-in the hash function for integer. All the basic type is a hash function for integer, for double, for character, for strings, all available. So you basically take a 6, 8, and 4, and 3, and create some kind of hash value, and then use the hash value to decide how they're going to be stored inside the unordered map. Okay, so you can see that. And so this is easy because our key is a primitive type, and system already know how to do it for us. Instead, and let's consider, hey, if we want to organize using map or unordered map for user-defined data type as keys. For example, in this cases, our map has a key is a 3D of int. The key is of this type, 3D of int. So for example, data could be like this. Now this key, system doesn't recognize how to create a hash, how to run a hash function for 3D object. Because of that, say for map, for example, map need to perform comparison. So in addition to specify the data type for key and value, we also need to create a class of comparator like how we did in homework 5. In fact, this is exactly how we did in homework 5. And I just repeating here. We have to define a way for system to know how we intend to compare the items. So compare 1. So if we go back here, we can see where is our compare 1 here. Okay. This is exactly like a homework 1. My class is a review of what we did in homework 1. So you have inside this class, you will define a function. You define the function. Function basically is operator parenthesis, operator bracket. This is basically a function. Inside function, we have a couple of constants here. Remember, the constants are necessary. No, we need all those constants, and we simply return. In our case, we return volume of between two 3D objects. Depending on your application, you can make the weight different ones. Okay, so I created this my compare. Last time, some student asked, if I have several things, can I have a multiple function and all put it inside a single comparator class? Answer is yes, but in general, I would suggest that always separate it because this class is very clearly only defined for their particular needs. They try not to mix with others, although we can put a multiple function all under the same comparator class name, but I would suggest that let's separate them. All right, so this is similar to our homework 5. And now let's see For the unordered map, it basically used as a hash. So the meaning that let me quickly draw a diagram to refresh your memory what we're talking about hash. Basically, for a hash table, we have some data coming in, and then it basically is the same as key. Okay, so data is the same as key, and some hash function. And then based on a hash function, create some kind of index, and actually being stored in the structure. Stored in this index, like position inside the structure we are storing. And in our case, this structure is an unordered map. Okay, so exactly where you store, you will be produced, you will determine by a hash function. If our data is of simple primitive type, system already provides needed function to do it for us, so we don't need to specify hash function. However, in our case, we are doing it for 3D objects, and the system has no idea how do we do hash function for the 3D. So it requires us to prepare our own hash function. In addition, in many cases that in a hash function you might have you can have multiple items with equal keys. So you had to check exactly which one you want. And so in addition to providing hash, you also need to provide something to perform comparison. Something to allow you to check how do you compare two items to be the same or not. Because sometimes you can have multiple data which after hash function identical index can be produced. So you need to compare them to see exactly which one is needed. Therefore, we need to provide two things. Okay, so we need to provide, say again, it's a map, so we need two pieces of data pair, key and value. And we have to provide hash function also is equal. There's a comparison to check what is the comparison, say, hey, to define in what way two objects are equal. And this part tells you in what way you want to use, ask the hash, provide the hash function for the whole hash table to work. So we have to provide this, also provide the equality checking. So you can see that in this case is for 3D object, we have provided that our hash function say, hey, giving any 3D object, we're going to produce, this is how we're going to produce the index, how we're going to provide the hash function to obtain the indexes. For example, we can see that what I'm doing is quite simple. I say, hey, for both, first, this is a hash, is a system, is a hash class of hash function, similar to class of function is a class. And this X is particular data type. In our case, X is integer, hash of integer. We create a function called H. Since this is a type, we can't directly use type. We have to create a function. And inside function, we say, hey, we create it. And since t dot height, each of them is of type integer, so we can simply create the index of each one, we multiply them and take a mod of 73. In fact, we can just multiply three things and in the end take a hash as well without having to do 73. In other words, I can easily do. I can depending on your application needs, we can do something like this as well. We can simply return h of height times width. depending on application need, we can simply do this as well. Just return the hash of height times width times depth. Again, all of this is controlled by user, and just give you an example here. And then we have to also provide equality checking. Say, hey, how do you intend to compare two objects of 3D types? In our case, I just like before here, I'm returning the volume of. If your application different, maybe you can compare height, width, and depth, making sure all three measures are identical. Okay, so we had to provide a hash function and provide an equality checking to a hash table here. All right, so you can see that our unordered map here. Okay, so with this tool, now we are able to really supply data to it. For example, we can have T1, 1, T2, 3, etc. And also, again, we can always add more items to it. For example, we can add we can just use earlier insert to add more items to unordered map. Okay, or you can always use insert. However, since this one is unordered map, just like a map, it won't allow duplicate. So meaning if you have a new item, you will overwrite all one. And of course, that another way to do this. Instead of using M5 of T2, we can simply say M6 dot insert. This tool will give out the same effect. So T2 100. Doing these two statements are identical. You can insert new one to it, or we can do it. Both will be acceptable. But look like insert is more universal. You can see set or map all use insert. Okay, insert is a general for many standard template library containers. All right, so this. And then the next thing is, let's see, for unordered map, there's also unordered multi-map. Unordered multi-map allows us to duplicate to have multiple items with the same key. We have 3, 2, 100, 2, and 2. Another 2 here is repeated. You can see that we have both Bob and Nancy both with the key value 2. And we can add more. We can insert another item with key 2. Now we have 3 items. So when you print it, you will see all 3. But now the key issue is that, of course, similar to in earlier, if you use a find, earlier we say, hey, for both map or set or all the earlier structure we have studied, such as list of vector, we can use find. But find usually will give us the first element that match. You only return the position of the first element that match the key value. But in our case, what if we want to? We want to print all items with all elements with key value 2. And how do we do this? And C++ introduced another structure, another function called equal range. Say for this, wherever it works for both this unordered multi-map or multi-set. As long as you allow duplicate, this function works, equal range. And say for example, for this M7, we search for key value 2. And an interesting part is that in the system, in this unordered map, so you have a number of items. And all those with the same key value, they are always stored together. For those elements with the same key value, in this case is 2 something, 2 something, 2 something. Okay, they are all stored in adjacent positions. So and this function, the function of this equal range will return 2 iterator position. First position is the beginning of all the items with the key value 2. And then IT2 is the one after the last one. All right, now that we have a range, we can then print all of them, all those items. For example, there's many different ways. This is N7. Say suppose after even though fully auto, this return is a pair of iterator. Okay. This return is a pair of iterator. The first iterator is a beginning position in the M7, and then the second one is the position right after the last one. So all of them, those are arranged for all those items with a key value 2. So now we can print all of them, and I say, hey, we can use for each, and this is from begin. Is the first is the begin. And second is the other, this 2 iterator. And then we can use a simple lambda expression to print out the results. We can take for each of the item I, we simply print this I dot first and I dot second. So make sure you fully understand this statement. Okay? This is the first time in the class we found out that for each cannot be replaced with regular for loop. Remember, for loop can do a lot of similar for each. Hey, but if you have to deal with, say, only perform operation within certain range of index, for each is the only way to do. You can use for loop. If you use a for, there's no way can you express something like this. Okay, so make sure this portion can be important for exam. So make sure pay attention to see how you can print multiple items from the map. If you have a multi-map or multi-set, it should be similar. Okay, so I intentionally include this here, so you know how to do this part of printing. All right, so, and keep in mind that regularly, for the unordered map, say, for example, so regularly, if you have a, say, unordered map, suppose we have a hash table, this time our key is a string. For example, can be string 1, string 2, string 3, long strings. For strings, system would be automatically handle hash for us. So we don't need to provide hash function because string is one of the primitive type. The hash function already available for strings, just like a hash function available for integer. So we are able to directly use without providing the hash function also for the equality checking because system know how to compare 2 strings. So we can easily do this, okay? And we can access and print everything out. Okay, so this is the first part that is relevant to the to this hash table and multi-set and multi-map. Important part is to know that if you want to use hash tables to handle the user-defined type, then you have to provide the hash function as well as the equality function in class. This is class, not an individual function, it's class. And this part also show you if you had to print multiple items with the same key, how do you do it? This part. Okay, make sure you read this, understand this 2 parts carefully, because in the exam I might ask you to do something similar. Next, I will move on to talk about exception handler. For exception handler, it's quite easy. From time to time in a program, especially say for a lot of the commercial tools, especially Microsoft or Windows or the Office, etc. On a daily basis, company like Microsoft will receive a report say, oh, you have a bug here, your program won't work in this case. So they receive hundreds, thousands, or tens of thousands of reported bugs every day. So would this imply that they will never release the software because the bug will never get fixed? And this is not the case. Now, usually when the number of errors are down to a certain level, they start to release the software. And then hopefully later on continue to provide patches for you to fix the bugs. And why would that have anything to do with what we are talking about exception handler? Say for example, if somewhere you have a two number x divided by y, and based on your knowledge, y can never be 0. So x divided by y is safe, you just go ahead and perform operation. But for some reason, y becomes 0 during some execution, and you have no idea what's happening, and you have no idea how to fix it. And all you're doing is just, for now, ignore it. Don't let it, just skip this division, so you can avoid crash the system, and let's get that program to work. Although from user point of view, sometimes they have see some very strange function, very strange behavior from the tool. So how is this being done? Say for example, inside the program, we can there are 3 important keywords: try, catch, and throw. Try everything within the scope of try called try block, and then within the scope of this catch side is called catch block. And then inside try block, there's another keyword called throw. Let's see what's happening in there. During your execution, if somewhere we have something right before you say I divided by j, hey, we check if j for some reason becomes 0. Although theoretically maybe in your program it shouldn't be 0, but now it occurred. Unless you spend a lot of effort going back to find out what's wrong and to trace it. And most of the time, you just quickly, a quick fix is not fixing. A quick action is simply ignore, don't provide this division operation. Instead, say if you detect it's a 0, then throw some kind of an error here, a string. And then on catch block side, you only care about data type. This is a string type. If it's string type, you will be caught by this catch block. You will directly come to this portion, because this one character string. This meaning is you will be catching you will be catching the string, and then usually we put a character, either character stop, but need to put a constant here. Again, this one inherited from C language anyway. If it's string, then it will be caught by this. If you simply throw integer, throw value 5, throw 5, and you will be caught by this catch portion. This catch block will catch it. Okay, so you only depending on data type. In string, you come here. If you simply say throw 5, or throw I, or throw j, okay, you will all come here. Okay, and the value will be the card as well. And then basically, depending on what you want, you can print it out. Say, hey, where error code, this value could be the error code. You can print 105, and you say, oh, it's error code 105. It might be meaningful for program developer. So again, based on data type, and then in the end, and also you can have a catch for int, catch for string, catch for double, catch for different catch for boolean, for example. And you also can have catch of ... is everything. If error is not caught by any of that, you'll be caught by this one. The universal catcher. It catches all messages not caught by earlier catch block. Okay, so once it happens, and once it throw some exception, and you'll be caught by catch block, and then continue from there. So you won't actually perform this operation. So it just allows you to skip some problematic thing, and maybe later on you'll come back to see why j accidentally will become 0. And once you fix it, then you can take away this throw statement. Now you fix it. Usually, they continue to include a lot of exception handler just to, for now, mask the bugs, and later on they might be able to fix it and release some kind of patch for you. Okay, so this is a basic idea. And this kind of in addition to a structure like this, we can also include a throw in a function. For example, I have a function like this, and inside a function I can throw exceptions. So this is a function tester. Okay, one can see that. Okay. So you can write a program, a trial block. In trial block, you can invoke some function, and that function can throw the exception message and get some catcher to catch the problem. All right. In addition to whatever message you can do in to report error, system also have a number of common one they use. For example, you have some. There are a number of system users say this is a generic exception, an exception and parent class. Under this case, you report this kind of exception or bad allocation, but you couldn't new something when you try to new an object and it failed for some reason, maybe with insufficient memory or anything, you would say bad allocation. Or in dynamic cast, it failed, and if you're using reference, you will report a bad cast. So you have a number of systems predefine the error message for certain special cases. Okay, I think that for this, at least I just want to point out there exist things like this exception handling, and this try block, catch block, and function throw. So I won't go deeper into that. And if you're interested, you can then read any article on this, either from any book or in internet. Okay, I believe that's all I want to tell you today. And I upload the code to Blackboard as well.